How's it, grade 11? So today we're going on to the graphs of E and Lin. For this video, all I'm going to do is I'm just going to focus on the graph of E, and then in the second video I will show you the relationship between the graphs E and Lin together on the same graph. So for now, just the graph of E. So as you guys know from this, y is equal to e to the x. That is an exponential function. So you can see it's going to go like this. How do I know it's going to go through 1? Because e to the power of 0 is 1. Okay, so it should cut through 1 always, unless we translate it up, down, left or right. Okay, another thing that I want you to know is a characteristic point. Okay, so e to the 1 is equal to roughly 2.718. Okay, and we can plot that. So when x is 1, y will be 2.718. And that is a point that I want you to plot. So there's 2 points on this graph that I would like you to plot. Is this, the characteristic point, plus the y-intercept. Now, just keep in mind that we could move this graph around or whatever, so the y-intercept could change and the characteristic point could also change. Another thing that I want you to notice here is that this graph shoots off in that direction over there. But over here, it'll come very close to your x-axis, but it'll never touch. And what we call that is an asymptote. Okay, so this over here is an asymptote to the graph, and the equation for this asymptote is y is equal to 0. Okay, because you can see our y value there is 1, y value is 0, y value would be -1, -2, and so on. So the equation for that is y is equal to 0. So 3 things from this graph: characteristic point, y-intercept, and asymptote. Okay, and that will help us plot these things. So if we go to the examples, our first example is asking us to plot y is equal to e to the x. Now, first of all, if I put 0 in here, I'm going to get 1. So I know it's going to go through 1 there. Also, if I put 1 in there, we know that our characteristic point will be 2.718. Okay, so when x is 1, we'll get 2.718, which is roughly about there. Also, I know that this here will be my asymptote. Okay, so my graph will come very close to this line. It'll go through 1, through our characteristic point, and it'll shoot off. Okay, remember, label your graph. So this is f of x, and then label your characteristic point. And this is 1, 2.718. And that is how I want you to draw your graph. Okay. Right, if we have a look at the second one now, what we're doing with this one now, if we look at our original graph here, or in fact I've got it over here, we are shifting it down by 1 unit. Okay, that's what this -1 at the end does. Or we could shift it up by so many units. So the plus will move it up, the negative will move it down. Okay, so first of all, you guys can see that our asymptote was over here. Y is equal to 0. Now this -1 is going to shift our asymptote down by 1 unit. So I'm going to draw in my asymptote here through where y is equal to -1. And I'm just going to label this, so we get y is equal to -1. Always label your asymptotes, grade 11s. Right, so now, what has this point done now? We've moved it down by -1. So 1 minus 1 will go through 0 now. So that point is now moved to 0. Okay. This point here was 2.718. It'll now go down to 1.718. So 1.718 is roughly about there. Okay. So it'll come very close to our asymptote. It'll go through our y-intercept, through our characteristic point, and then up. Okay. Remember, label your graph, f of x. Then also label your characteristic point here, which is 1.718. Okay. Going on to the third example. So now we're doing 2 things. First of all, we're moving it up by 1 unit. So our asymptote will move up. Also, we are making it grow a lot quicker with this 2 in the front. So we're multiplying it by a scale factor of 2. Okay. So first of all, if I look at the original one, our asymptote was at y is equal to 0. We are now moving it up by 1 unit. So our new asymptote is going to go through y is equal to 1. So I'm just going to draw that in. And label it. Y is equal to 1. Okay. Now the next thing is this point over here, our y-intercept. Now there's going to be two things that's happening with this now. First of all, we're shifting it up. Then it's going to be multiplied by a scale factor of 2. Okay. So what I do first is just make x 0. All right. So e to the x or e to the power of 0 is 1. 1 times 2 is 2. 2 plus 1 is 3. So this graph is now going through 3. Okay. Next, our characteristic point, this point over here, was 2.718. Okay. So what I do is I take 2 times that 2.718 because we're multiplying it by a scale factor of 2. Then I add 1 to it. And we get our new characteristic point has now moved up to 6.436. So when x is 1, sorry, I just want to draw an extra here. So we get 6, and then that would be 7. We would get 6.36. So 6.36 is about over there. Okay. Comes very close to our asymptote through the y-intercept, and then it exponentially grows straight up there. Okay. Label our graph, f of x, then label our characteristic point. So this was 1, and we said that was 6.436. Now what I want you to notice here, grade 11s, is see how much quicker this thing is growing, just because of that 2 in the front there. Normally, yes, it does grow very quickly, but now you can see it's growing a lot steeper. Okay, so we're going on to example D now. F of x is equal to minus e to the x minus 1. Now, with this one, grade 11s, it's going to be a little bit different because we're not shifting it up or down, because you can see that this minus 1 is with the x value. The up or down shift will be something at the end here, either plus something or minus something. When you get it here with the variable, it's going to be a shift to the left or to the right. Okay, so basically what we're going to do is we're going to take this original graph, pick it up, and then just move it left or right. Okay, so the best way to handle one that's like this is to plug in your characteristic points. So first of all, we know that 1, or x being 1, will give us a characteristic point. So that's what I'm going to do here. So we've got minus e to the 1 minus 1. So I've just made my x 1 for my characteristic. And we're getting minus 1. So at 1, it's minus 1, and then I can put the dot there. Now you're probably thinking, well, all of our characteristic points were above the x-axis. Why is this one below? It's because of this negative over here. And what this negative has done is done a reflection of our original graph about the x-axis. So it's basically flipping it like this. Okay, so it's going to be a mirror image just on this side, and it's going to be coming like this. Okay, so we haven't changed the asymptote. The asymptote is still this line over here, your x-axis, because we haven't added or subtracted anything on the end there. Now, the problem comes because we're moving it left or right. Basically, think of the original. If I pick it up and I move it right, you can see that by 1 unit, you can see that this point here will now move over here. And now that will be our y-intercept. So that's what we need to find here is now our y-intercept. So I've just written it in a different way. It's exactly the same. Y is equal to minus e to the x minus 1. How do we find y-intercepts? By making x 0. So y is equal to minus e to the 0 minus 1. And that will give us y is equal to, just do it on your calculator, minus e to the 0 minus 1. And we're getting a y-intercept of 0.368, which is, that's 0.5. It'll be about there. Okay. So just remember that the graph has flipped now. So your asymptote hasn't changed. So your graph is going to come very close to the axis here, through our y-intercept, through the characteristic point, and it's going to shoot down like that. And we can call this f of x. And then just remember, label your characteristic point. So that point there was 1 minus 1. Okay. Thanks, grade 11s. So what you can do now is your homework will be, just want to get it here for you guys. It's just going to be this one over here. Just this first part here for your E functions. Okay, and that's on page 53. Okay, thanks grade 11s.